Hi, welcome again. Today we are going to learn unary operators. Unary means single. Okay, it requires single operand. It requires single what operand. Which are the unary operators? This is called unary minus. This is called increment operator. This is called decrement operator. This is called inversion operator. Inversion. This is negation. This is size of, that will give you the size of. This is called address of operator, address of. And this is called indirection operator, indirection. These are the unary operators are there, and we are going to learn how to use them. Okay. So how the unary minus works for you. Okay. I write like this: integer x is equal to 7 and integer y is equal to minus x. Okay. This is different from x minus 2. This is a binary minus. Why? Because it requires two operand. This is a unary minus. It requires what? One operand. What it does? We know very well whenever I solve an expression, the result will be stored in a register. Okay, what this operator does? It negates the operand and puts a value in the register. That's it. Now this register value will be copied into what? Y. Therefore, if I print my x remains what? 7. My y is going to become minus 7. Now, this is a unary minus, okay? So, the minus has to come always before the operand. It can't go after that. You can't write like this, x minus. It can't be written. Yeah? The next is called the increment operator or decrement operator. Let us see here. Increment operator, what it does. I've written like this: integer x is equal to 7. If I say plus x, what it does? I'm going to store the result in y. Okay. Now x is a memory location which is storing 7. Now what the plus x does? This operator is capable of changing the value of the operand. So far, no operator was capable of changing the value of the operand. Plus x. It goes to the x and increase x value by 1 first. Therefore, it became 8. Now, after increasing it, it is going to come and put it in the register. Now, what is in the register right now? 8. The 8 will be copied into y. My y will become what? 8. That means after this statement, if I print x and y, both will be what? 8. Remember, both will be what? 8. It increases the value of the operand by 1. Therefore, for this operator, you cannot use a constant. You have to use only what? A variable. That operand has to be a variable. Remember that. Now, if I say here same thing, if I write here right now, my x value is right now in this case, let's say in this case, my integer x is 7. And I have put right now, integer y is equal to x plus plus. What it does? See here, my x value is 7. Now, what the x plus plus does? Before it increases, it substitutes the value of x in the register. Then it goes to the x and increase x by 1. This is called post increment. Why is called post increment? It substitutes, then it puts it. Now that means after this statement, if I print x, my x would be what? In this case is 8. My y would be 7. Remember, here in this example, my y was 8. Here y is what? 7. Why? Because what I'm going to copy it in my variable. What I'm going to use it, I won't use the x value, I'll use a register value only I'll use. Now you can understand here what would be the output if I say here in this case x. I have written here my x is right now 7. I put here integer y is equal to minus x. If I say minus x, what is going to happen? Yeah, x value is 7. X value is what? 7. And I put here right now in this case is minus x means it is pre. That means first is going to decrease it by 1. Then it will come and put the value 6 here. What I am going to copy, what I am going to use it what? The 6. Therefore my x would be what? 6. Y is also 6. Whereas instead of writing this, if I could have put an x minus minus, what would happen for me? My x would be 6, my y would be what? 7. Why? Because before it decreases, it substitutes a value of x in the register. That will be copied into what? Y. Okay. So the next operator we are going to learn is what is a inversion operator. What the inversion operator does? Okay. The inversion operator does like this. If I say like this, I have written here integer x is equal to, it can be only applied for integer, okay? I put here 18. If I write an inversion of x, it creates a register. The result is copied into a register. You can copy it in a variable. What does this register contains? All the binary form of 18 is being inversed. What is the binary form of 18? If you know, it is 1 0 0 1 0 0 1 0. 2 raised to 0, 2 raised to 1, 2, 3, 4. That is 16 plus 2 is what? 18. Okay. So the remaining bits are filled with what? 0. Okay. The first bit is a sign bit. If the sign bit is 0, means the number is positive number. Inversion of x is what is going to do? It's going to inverse every bit. This will become 1, 1, all 1, 1, 1, 1, 1. This will become 0. This will become 1, 1, 0, 1. This is the x. This is the inversion of x. Now, what is the value is stored? How do you know? As I told you before, if the first bit is as 1, sign bit is 1, you can't calculate 2 raised to 0, 2 raised to 1. You can't do it. Okay. What you need to do, you have to convert the number to a positive. I will convert the number to a positive. Simple thing. Subtract 1 from here. If I subtract 1 from here, it is 1 minus 1 is what? 0. This is 0. 1, 1, 0. 1, 1, 1, 1. All are 1, 1, 1. Right? Now what do you do after this? You need to inverse the bits again. 0, 0, 0. 0, 0, 0, 0. And 1, 0, 0, 1, 1. That means what is the value is 2 raised to 0, 2 raised to 1, 2, 3, 4. 16 plus 2 is 18, 18 plus 1 is what? 19. It says this process you followed, therefore you say minus 19. Whenever your sign bit is 1, you can never get a value directly. You have to inverse the bit and what? Do it. Okay. So let us see whether it is what I said is right or wrong. Okay. So let's go and see here what I can do. I have written like this. Okay. Integer x is equal to, what I wrote what? 18. Integer y is equal to inversion is just above your tab before 1 it will be there. Okay. Inversion of x. You can use it for constant also. I am going to say printf percentage d slash n comma what x printf percentage d slash n comma y, and I'm going to run the code. I got minus what? 19. What about if my x would have been 18? Minus 18. Sorry, if it is 18, what would the answer I could have got? Inversion of x. I got 17. Why? Okay. So let's say in this case is minus 18. Now we need to get the binary form of minus 18. Okay. So let's go. We'll get the binary form of minus 18 and we'll see. What is the binary form of minus 18? So how to get the binary form of minus 18? First is you get the binary form of 18. First you get the binary form of 18. We saw binary form of 18 is 1, 0, 0, 1, 0. The remaining all bits are filled with what? 0. 32 bits. Minus 18, what you will do? First is what? Inverse the bit. All will be 1. This will be what? 0, 1, 1, 0, 1. Then what you need to do? Add 1 to it. If you add 1 to it, 1 plus 1 is what? 2. 2 means you will write what? 1, 0. You will put the 0, will carry what? 1. Here 1, 1, 1, 0. All will be 1, 1, 1. This is the binary form of minus 18. Now, when I inverse it, what happens? This will become 0, 0, 0. All are 0, 1, 0, 0, 0, 1. Right? What do you need to do? You have to make what? Now, first bit is a sign bit is 0. Therefore, you can calculate 2 raised to what? 0 and 2 raised to 4. 16 plus 1 is what? 17. I got 17. That's the way the answer I got. Okay. But for you to understand very simply, okay, you don't need to do every time. Okay. If your number is positive, inversion will make it to negative. Okay. Inversion will make it what? Negative. Same way, if a number is negative, inversion will make it what? Positive for you. Now, if the number is positive, if I say here, if my x is right now 17, 18, what the inversion will do? Make it negative and increase it by 1. It will be minus 19. Okay, what about if the number is negative? What will do? Inversion will make it positive and subtract it by 1. That's it. Okay, simple thing. Inversion, if the number is positive, make it negative, increase it by 1. If it is negative, make it positive, subtract it by 1. Okay, that's simple for you to understand. Okay, now the next is we have something called the cast operator. What is a cast operator? Okay, so now I have written like this: integer x is equal to 7 and integer y is equal to 3. If I say x divided by y, what the system does, it copies a result in the x value in a register of type integer, y is in a register of type integer. It copies, that means 7 by 3 is how much it is going to become, supposed to be 2.33, but no, why? Because both are integer, therefore my register is going to become what? An integer, copies only 2. Therefore, even in my z, even if I make a z as what? Float, my answer is going to be only 2.0. Note that I want 2.33. Okay, what to do in this case? One option is you can make x or y as a float. Other option is you can tell the system store the x value in a register of type what? In a register of type what? A float. I will say by simply writing before the x in a bracket float. If you put a float, what is the meaning of this statement is it copies the x value in a register of type float and then divide by x. X is an integer. I am going to get 2.33. Why? Float by integer result is what? This. If you store it in a float, you will get 2.333. If you store it in an integer, you will get what? 2. That's it. Got it? Yeah? I hope you have understood this. Therefore, the cast operator tells a system to store the result in a register of the data type. Register of the data type. Let's take one small another example. Okay. So let's say in this case I have written like this. I have written here in this place integer x is equal to 7, float y is equal to 3, and I have written x mod y, and I want the result. I want the result in an integer. Will it happen? No. Why no? Why? Because modulus cannot be applied for what? Modulus cannot be applied for float or a double. So what you do in this case is you tell the system y value don't store it in a float, store it in an integer. Done. In this case, it will become what? An integer for me. I am going to get x7 modulus 3. So how much I get what? 1. Okay. This is the purpose of the cast operator. It's called cast operator. Next is here in this case is we have a size of operator. What is the size of operator does? It tells you how many bytes is allotted for a variable, constant, or an expression. Okay. So let us see here how I should use a size of operator. So I have written here size of in I have written x. X is what? Integer. Okay. If you want to know how many bytes have been allotted, simply say size of x. Size of x will give me what? How many bytes is allotted for this? Now I'm going to you may get a warning. We'll solve the problem. See the warning. It says it is an unsigned integer. The size is an unsigned integer. It says therefore long unsigned integer. Therefore, what's the format specifier? LU. You need to use LU because size of gives you in an unsigned form. 4. If I say here right now in this case is size of double, what is going to give me 8 bytes. If I say here size of, if I say here right now size of 3.5, what I should get? 4 or 8. Okay, let us see. I got 8. Why 8? Because 3.5 is by default, it is double. Any fractional constant in C, C++, Java is double only. Okay. If you want to make it float, simply put an F after this. You'll get 4 bytes. If you put a F after the fractional constant, you'll get what? Okay, let us see here in this case, what about single quote character? If you put, what will happen? Okay, it is going to give me what? 4 bytes. Why? Because in this place A does not exist. What exists? What? 65. 65 is an integer. Therefore, I got what? 4 I got. Okay, sir, I have written here right now in this case. If I put here right now in this case, what happens if I put here x into 2.5? The result will be stored where? In the higher data type. Who is the higher here? In this example, the higher is what? A double. Therefore, my double is 8. Okay. So, size of operator tells you how many bytes have been allotted for a variable, constant, or an expression. Okay. This is what is going to tell you. So our next operator is an address of operator and what? An indirection operator star. Okay, what they are used for. And this is if you use both the sides operands, it will become a binary. If you use one side is a unary. Unaries will give you address. Binary will give you what? Bitwise it will make. Okay, it will make a bitwise operations. Remember that. Okay, we already done in bitwise operators. Let us see. I've written like this. What is happening? Let us understand. I've written x is what? 7. When I write x is 7, in my RAM, 4 bytes have been allotted for x. Inside the 4 bytes, 7 is stored in binary form. Every byte in my RAM has an address. I'm assuming the first address 115, 116, 117, 118. 4 bytes have been given. Okay. Now, when I say here in this case, if I say here x, if you put an and x, what I'm going to get? I am going to get the first address of x. First address of x. So if you want to print and see, you can print and see. Printf percentage LU. Why? Addresses always an unsigned integers. I will get 115 in my example. If you run it, you will get something else. Okay. Now in the scanf, why did you put an and x? Why do you put an and x in the scanf? Is because you are telling when I write a scanf percentage D and X, what you're saying, whatever I scanned, take to this address and store it there. That's it. Take to this address and what? Store it there. That's what you said. Okay. Nothing else you are saying. Therefore, while scanning, I need to provide the address. Okay, sir. Now what is going to happen? Okay. Now X means I get what? 7. And X means what you get what? 115. But if I put a star before it, it will give you value inside the address. What is the value inside the address is what? 7. Sir, if 7 is stored in 4 bytes, oh, it will give you 4 bytes value only. I'll get 7. This is called indirection operator. We are going to study this in very much in detail when I deal with pointers. Okay, right now it's fine. Okay, yeah. I hope you have understood all the unary operators. Okay, now let us move to what are assignment operator. How the assignment operators are used here. Okay, which are the assignment operators are? Okay, now I put here right now. It's called simple assignment operator. Then composite assignment operator. What is a composite? Plus equal to, minus equal to, multiplication equal to. All the binary operator which you have used can be combined except greater than or equal to, less than or equal to. Why? Because they have already used. Now all you can use here, right shift equal to, left shift equal to, and equal to, double and equal to. All this can be combined except you cannot combine a relational operator because they have already combined. Okay. Now whenever you write any assignment operator, there is two sides. One is left hand side and the right hand side. The entire right hand side will be solved first and the final value will be carried to the left hand side. Entire right hand side will be solved first and final value will be carried to the left hand side for every time. The left hand side must be a single variable. Must be a single what? Variable. Must be a single variable. Remember that, okay? Right hand side can be anything that produces a value here, okay? So what is the meaning of this statement? So can I say here right now, can I say x is equal to x plus y? Can I write it? Yes, you can write. Your x and y should have a values, okay? Can I say x plus y is equal to z? Can I write it? No. Why? Because the left hand side is not a single variable. Can I say right now 10 is equal to 9 plus 1? Can I write it? No. Why? Because left hand side is a constant, okay? Can I say here right now into equal to 5? Can I write it? Yes. What is the meaning of this statement? This is, see, the into is before the equal sign. Remember, this statement can be written by you as x plus equal to y. Remember, it can be referred as what? X plus equal to y. Okay? X into y is equal to x is equal to x into 5. That's it. Okay, now x into 5 can be written as what? X into equal to 5. Let's take another example. X is equal to 7. Can I say x plus equal to 2 into equal to 4? Can I say why no? Left hand side of the assignment operator cannot be a constant. It has to be a variable. Okay, done. Now what to do, sir? Can I say x plus equal to x into equal to 4? Can I say yes? Why? In this case, what my x value was? 7. Now, when you have a multiple assignment operator, to move from right to left, okay? First you will solve this. X into 4. How much it is what? 28. Therefore, my x became 28. This 28 will be added with x. What is already x is what? 28. 28 plus 28 is what? 56. Therefore, my x will become 56. Okay, got it? Yeah. Okay, so now let's go to the selection operators. Which are the selection operators? One is dot, other one is arrow, other one is what? Dot star, bracket, and brackets. These are the selection operators. How to use them? We will study along with the topics because right now it's too hard for me to explain them separately. I'm just making you to remember this. We will come back afterwards. Okay. Once again, I would like to remind you the assignment operators are simple assignment, composite assignment, plus equal to, minus equal to, multiplication equal to, all the binary can be combined with the equal to, except greater than, less than cannot be done because they have already combined. Okay, yeah. So I hope you understood this, and I hope it's beneficial for you. And I would like to be, I would like to remind you, if you have not subscribed, kindly subscribe, and please share with your friend and like the video. And whatever the comments you have, please raise it to me. I will solve you immediately in the comments itself. Okay, thank you so much.